So we're going to continue where we left yesterday, in the sense that we are going to have an analysis of the wave particle, these ideas, corpuscular and wave ideas, in terms of some concrete, in terms of some experimentation, thought experimentation. The way, so the background may be that of how we analysis of interference experiment. So we are going to so how to do away, or how to just explore the quandary of this wave particle duality in some sense, in a given experimental setting, which you can theoretically at least imagine, and try to iron out the contradictions or the differences, at least in terms of how we conceptualize things. So for example, if we have a source of radiation A, so it passes through a screen, this, and there is another screen. So we'll say this is a diaphragm, and this is a screen. So you can see light has come here, it has diffracted. So we say that what's the probability of A, it has come here and it has diffracted. So the probability of radiation which comes out in a certain interpretation of probability, it may be the probability of A and probability of B, depends upon how the probability was here, probability is here. So what we are going to, the probability of this flash of light being observed here depends upon how we see the joint probabilities of this from where you have observed it and the screen from which it got diffracted. Such that particle which is living at A, if you have a particle interpretation which lives at A, will arrive at B and probability is probability of A times A dot B times C. So particle is living A, diffracts B, and it arrives at C. So the thing is that one is known as phenomena, and other is previously something called interphenomena. So interphenomena means a phenomena which is interrelated with some another phenomena. So there is a causal interdependence or of events, of a given event in relation to other events, which may be simultaneously or occurring, or it may be occurring with some time lag or delay. So what is the deviation from classical physics? Deviation from classical physics or classical way of understanding things is that so we have a probability law, which governs how there is a transition from B to C, transition from B to C. But this should equally also hold for in case of quantum mechanics also. So if it should be true for a classical world, the probability of A reaching there, it's also dependent upon B, the transition. So if it's true for classical world, it should also be true for the quantum world. And according to strict causal laws. So as long as the wave is entering here and it goes there, so there's no problem. But once it comes, it goes through this, and there is you observe some flash or some blob on the screen. So you will say, so, okay, the wave has reached here. But where is the other part of the wave, which was part of it? So the classical way of looking at it is. Things have got diffracted, and where there's a maximum interference, you might observe the thing there. But the point is that where is the other part of the wave? So here you can see that it has not yet reached the screen. So we'll only observe the flash which is on the screen C. So this process of not observing the wave, in the classical sense, will lead to sort of an anomaly. The causality seems to be somehow not. What I should say, causality seems not to be absent. So we use the word causal anomaly. Causal anomaly, you can say it in that sense, in this description, which otherwise in normal description, in the wave description, we should not. We should simply say it. The wave has just propagated. It's not that mere blob on the screen, which will give you that indication of wave is out there only. That's it. So within wave interpretation. You cannot deny this legitimacy of asking this question. Now, if we again in the context of not only we are interested in phenomena, we are interested. It's not phenomena; it's interphenomena. So an event is not. We have a simultaneous event which is related to this event, which will produce an effect out there. So event is related to something as a source, and that source which creates that event, it's not created by that source only, but that source is also interrelated with other source or other things. They are simultaneously connected in the interphenomena. So we have to modify it. We modify this experiment rather than a source of radiation. This source of radiation, we are going to have. Rather than it passing through B, we'll say it has passed through this B, and again its effects are going to be seen out there. So the question is again, so if there is a source here and we have a sort of a diffraction here, and its effect in terms of blob or in terms of short or in terms of a bright spot we have seen there. Now question is again, if we open this pinhole also, and again a source of light comes here, so again we are going to see the effect here. Now again the question arises whether the effect it's produced here was it produced by this amplitude, this light wavefront, or this wavefront. That's the question. That's a question. Ah. So we have to we have to have the courage to face this consequence, which is we have to have the courage to have this interpretation, whether it's due to B1 or whether it's B2, the effect on C. So again, so earlier the causal anomaly was that where was the other part of the wave, if its effect is only observed here. Now the effect is that so the cause of this thing effect, whether it can be traced by this path or by this path. So it's maybe double confusing for us. That's it. So if we want to just see the language of probability, we'll just see rather than how can see the total probability of A, C will be probability of. So if we want to but from the calculus of probability, what's the probability of radiation A reaching there? So it will depend upon probability of A times B1. This is 1, B1C plus probability of A times, this is B1, this is B2, times probability of A times B2 into C. And so it's the meaning is vis-a-vis, we can have to see its meaning vis-a-vis how we see if it's 1, so if it's 2, so it's 3. It's 3. So the question is the question we'll see. Question which arises is the pattern of interference same as that which will result when both slits are opened simultaneously. So is this is the pattern of interference seen as that which results when the both slits are open simultaneously? Now again, so there's this thing. So if there's a time lag, so one is that you have opened one, you will have effect here. The other is you have opened this pinhole and this pinhole, and you have observed the effect here, but you are not sure whether the effect observed here is due to this, or due to this, or due to combination of both. Three possibilities are there. Now the other possibility is that if you have some lag here, you just open this first, you open this later, you open this later, or you open this first, or you open the both of the slits simultaneously. So these are different possibilities. So what is the thing is that what is the effect which was observed out there? That's it. So question is that so if it's if it was opened here and the effect was opened here, so you can say also one thing is that the effect which was observed here was basically the simultaneous effects, which was the effect of this and this together. So the simultaneous, so it's also sort of a causal anomaly is also there. The strict definition of causality, that a single effect can be traced to a given cause, somehow seems to be not complement, that's under this stress. So you have simultaneous causes may produce a desired effect, which is there. It's not desired an effect which is observable, if we have observed. Modulo the fact, so if we say it's a particle embedded, so the effect is here, that we can say that in terms of wave interference, we have seen the effect of the wave here, that's it. So we can say, now the author says it will be erroneous to believe that because of if there are causal anomalies which are not able to explain things, that the particle interpretation, that if we say in terms of we observe this wave particle duality as if as an effect in terms of corpuscular thing, it is somewhat having problem. The corpuscular interpretation of waves has some problems. So it sort of reminds us of something of a simultaneity in special theory of relativity. So when we talk of an event happening out there, whether two observers are observing an event which is out there, so are they observing that event in their own simultaneous times? Because each individual observer has its own clock. We sometimes devise something called metric simultaneity, where we just assume that the distance between 2 points is the same, and we can assume that an event which is observed by a point here, observer will also be observed simultaneously, even though they have two individual clocks. So that analogy or that thing can be just made out here. It will have some loose, what I should say, parallels here, such that what the particle passes through B1 is in the same sense. In the same sense, we have used the sentence particle has passed through B1 is as if it has passed through B2, such that effect which is observed out here, it's the joint effect of they are going to simultaneously produced by both of them together. So we can have this thing, this analogy. But in some sense, it will, what should say, something called, if you remember in classical mechanics, or if you something called action at a distance, means that it takes, for a given, if a particle is in gravitational field or an electric field, it takes some amount of time for local fields for an event to be the effect to register an event after some time. So it's not that the effects are non-local or simultaneous in that sense. So there is no spreading of effect, no spreading of effect from B2 to B1, or change of shape such that it will be. Now, if you want to just construct an experiment which is independent from the interpretation of these anomalies, the violation of these causal anomalies, what we should say is that we should have an interpretation of, for example, these waves, where these interference of them in terms of what I should say. We should have an interpretation of them in some ways. We can have so two canal sort of a system where we can have blackenings on the screen. So it's not that will not also create much effect that if we want to just increase the spread of radiation along some canal, and we can just maybe make the effects more pronounced on the screen, if that's the purpose. That's the way we can do away with the problem. As Einstein originally assumed him, so in the needle radiation. But the thing which we want to say here is that what are the, if you want to just boil it down, this thing to something very much if we want to see what is if the wave interpretation and the particle interpretation, what is it there, where we can break it down. So the wave interpretation, because there is interplay of causality, which is somehow seems to be not violated in terms of these causal anomalies, but this wave interpretation, if it is to be seen as a following Schrodinger equation. Schrodinger equation is also a wave equation. It's controlled by a partial differential. Schrodinger wave is a partial differential equation. So it doesn't allow a spatio-temporal description of physical objects. So there's a, so if it's a wave interpretation is given in terms of so it doesn't have a spatio-temporal description exactly how it just gives it. So this is one limitation of Schrodinger equation in this sense. And if we have a corpuscular interpretation, it will requires a spatio-temporal description, but at the cost of causality. So, which we have seen, the causality seems to be somehow, it seems not to be violated in terms of, no, in terms of causal anomaly, the way we just try to see it. And spatio-temporal order means how things evolve in space and time. There can be causality, there can be causal order to it, or how in space and time things evolve. So you can say that spatio-temporal order is connected or related to causal order. In the sense, you can, there's a teleology associated to it, whether we talk of space-time, time-life, or light-like units in relativity, that's it. So the what our exposition of this description of this experiment, thought experiment. So the problems involved in quantum mechanics cannot be reduced to alternative. The alternative may be whether we can have a binary of space-time versus causality. So the way we interpret the violation of causality, there can be some interpretations are associated with it. How we can say that causality has been violated? The violation of causality may be either that the interference effects have been observed. Still, whether we keep one hole open and not the other one, still we can observe the effects here. But once we open both, so we don't know the effects which was produced here was due to this thing or this thing, the light passing through this thing or this thing. Or even if we had a time lag between the thing, the temporal order, whether it was first produced by this or it was later produced by this thing. So these are different violations of causality, both spatial as well as temporal in terms of. So that's the problem of quantum mechanics cannot be reduced to alternative. So we have, there can be alternative interpretations to these things, how violation of causality can be there. And there can be, Reichenbach has added a third violations. Within the third interpretation, we must mention, which is a combination of both wave as well as particle. So in the third interpretation, where these are two interpretations. The third interpretation says that it's combination of both wave and particle interpretation. And so the way we try to appreciate these pilot wave idea of de Broglie, that the field spreading through a whole space being diffracted is usual way. In addition, we have particles whose movement is controlled by sort of a pilot wave. Such that intensity of the field is determined by finding the probability of the particle. So it's a sort of wave, but somehow particle will where its maximum, the particle determines how the wave, where the wave is going to get propagated. And for the influence of the field, influence of field on particles is governed by unusual laws. So, but the particles cannot move in the straight lines. It will violate causality in that sense. Because because the particle passing through B1, will turn in the direction of C. Depends also not on intensity of V1, but on its intensity at C. So if it's not in straight line, so it will only have to depend upon this only. If the impression is to be seen this way, then only we can say the particle has moved only in the straight lines. Otherwise, if we assume that the effect which was there, it's due to both of them, so not necessarily the particle here may not necessarily have moved in that straight line, or that way we define causal order, spatial causality. Uh, um, Spatial causality. Causality is related to different points in the space. They have some order attached to it. So that seems to be violated. So maybe in the coming class, what we are going to do is we are going to have more something called exhaustive and restrictive interpretations. With these vis-a-vis these causal anomalies, which we have studied. Some part of it will continue in the class.